This star is quite enormous. During the day, stars give off warmth and light, while at night they shine brightly. Animals and plants flourish on Earth thanks to the sun's light. From our limited perspective, the stars, even the one at the center of the solar system, may appear little. But that is not the case. The universe is vast. On Earth, it's impossible to go very long without seeing the sun. Because it is the largest body in the solar system, this enormous ball of atomic fire rules the sky. Yet the sun isn't that enormous for a star. In fact, it's about average in size. So, are there any larger stars in existence? What is the name of the largest star known to exist in the cosmos, and where is it? Let's find out. How do stars work? We must first define a star before discussing the biggest star ever discovered in the universe. A star is a large, bright astronomical object made of burning gas that emits radiation as a result of internal reactions. Although hydrogen and helium make up the majority of stars, other elements can also be found in them. Moreover, there are a huge number of stars in the universe. The universe is rich beyond measure, according to Carl Sagan, who also noticed that there are more stars than there are sand grains on all of the planet Earth's beaches combined. According to recent calculations, the observable universe contains at least 1,022 stars. We only perceive pinpoints of different colored light from our vantage point on Earth. The stars are obviously considerably bigger. Over the course of their lives, stars change in size. Like all other living things, they have a life cycle, and the stage of life that they are in strongly influences how big they are. Let's quickly review the life cycle of a star. You will then have some background information when we discuss star size. A stellar nebula or cloud of gas and dust is the precursor of every star. This celestial nebula experiences gravity over millions of years, creating protostars, pre-main sequence stars. These protostars' lifespans depend on how much mass they accumulate. If a protostar is unable to accumulate enough mass and attain the necessary temperature for hydrogen fusion to begin, brown dwarfs are created. A substellar object is what this is. Main sequence stars are stars that do become big enough to begin nuclear fusion. When they run out of hydrogen, smaller stars, roughly the size of our Sun, will have billions of years to live. The star's temperatures will rise and they will shatter into smaller stars. It can take hundreds of millions of years for these stars to expand and develop into red giants. Mercury, Venus, and Earth will all be swallowed up by our Sun once it eventually turns into a red giant. These stars eventually collapse and turn into white dwarfs, which eventually turn into black dwarfs and stop emitting heat. Hydrogen depletes significantly more quickly from massive main sequence stars than from tiny stars. They then enlarge and develop into gigantic red giants. They eventually fall apart when fusion stops, which results in a gigantic explosion known as supernova. Black holes or neutron stars could develop from these. As you can see, a star's life cycle is complicated and can result in a wide range of sizes. So how big is the Sun in our solar system? Our solar system's Sun has an 865,370 mile diameter. It is a dwarf star in the main sequence. In another 5 billion years or so, it will run out of hydrogen, at which point it will eventually turn into a red giant. The diameter of the Earth is 7,917 miles. The Sun is therefore roughly 109 times wider than the Earth. Obviously, when the Sun evolves into a red giant, this size will vary in the future. What is the largest star that is currently known to exist in the universe? Stephenson 218, a star with a radius 2,150 times that of the Sun, is the biggest star in the known cosmos. Its size is 930 million miles, or nearly 10 billion times the Sun's volume. The Earth is essentially a speck of dust in comparison to this star, and the Sun is incredibly tiny. The fastest plane on Earth would need more than 500 years to complete its journey around Stephenson 218. At the speed of light, it would take almost 9 hours. Its diameter is the same as Saturn's orbit. It takes 19,000 light-years for the Stephenson 218 to reach Earth. It is in the same galaxy as the Earth because it is situated in the Milky Way's Scutum Centaurus arm. Our perspective on the observable cosmos is something to think about. We can only guess about the greatest size of stars because the numerous stars in the universe are hidden from our vision. Most likely, we don't know which star is the biggest in the cosmos. A red supergiant of the spectral type M6 is Stephenson 218. At a radius of 2,150 solar radii, it is one of the biggest stars ever found. It is also one of the red supergiants with the brightest known surface. It has a 3,200 Kelvin surface temperature and emits 440,000 solar luminosities. But there is a lot of disagreement over how big this star is. It's challenging to obtain an accurate measurement of this star due to its proximity to a cluster of other large red supergiant stars, as well as other considerations. In reality, it's possible that the star is not as big as the second biggest star in the cosmos. The title of the largest star was won by Stephenson 218 from the previous record holders. The largest star in the known cosmos, assuming the Stephenson 218 is not larger, is known as UY Scuti. This star's radius is around 1,708 times that of the Sun. The Stephenson 218 may not be accurate because there is a margin of error of about 200 solar radii. How does UY Scuti compare to Stephenson 218? UY Scuti is located in the constellation Scutum, which means shield, around 9,500 light-years from Earth. It is a red supergiant that is around 1,700 times bigger in diameter than our Sun and is enveloped in dust. German astronomers J.C. Müller and P.R. Ritter discovered it for the first time in 1860 at the Bonn Observatory, where they gave it the initial designation BD 125055. Yet it wasn't until 2012 that a team of astronomers working with the Very Large Telescope in Chile was able to confirm its astounding size and demonstrate how the huge star changes in brightness over 740 days. Due to this tendency, UY Scuti is categorized as a variable star, a category of star that frequently grows and shrinks as its brightness varies. If UY Scuti were to replace the Sun as the primary star of our solar system, its photosphere would reach beyond Jupiter's orbit, giving you a sense of its size. Jupiter and the Sun are separated by 484 million miles, or 779 million kilometers. A 400 astronomical unit long nebula would be created by the star's gas. 1 astronomical unit is the distance between Earth and the Sun. In practice, this would extend far beyond Pluto's orbit. 39.5 AU is the length of Pluto's orbit around the Sun. So what accounts for UY Scuti's size? Its makeup holds the key to the solution. A red supergiant, or a star that is nearing the end of its existence, is UY Scuti. These kind of stars have started to fuse helium after running out of hydrogen to burn in their cores. The star grows and cools as it continues to fuse helium, eventually growing to be one of the largest and coolest stars in the cosmos. There is a problem though. Due to its propensity to fluctuate in size, we are unsure of UY Scuti's exact size. The fluctuations in its radius, determined with an uncertainty of roughly 192 solar radii, coincide with the brightness shifts we previously mentioned. If the lowermost number is accurate, other stars may then be actually larger than UY Scuti. That means roughly 30 known stars would be larger than UY Scuti's least estimated size. Its crown will eventually be overtaken by one of those stars because UY Scuti is too big for its own good. Because of its size, its outer layers can't be held in place by gravity. UY Scuti is thus losing mass at a startling rate, losing 20 million times the mass of the planet annually. The star is heating up and contracting because of this mass loss, and it is predicted that UY Scuti will shortly enter the supernova phase. When UY Scuti ultimately bursts into a supernova, it will be one of the most spectacular displays ever. Because of how bright the explosion will be, it will briefly eclipse the entire galaxy. The supernova's afterglow will also be breathtaking. In addition to leaving behind a stunning ring of gas and dust known as a supernova remnant, the explosion will produce new elements, providing the cosmos with the raw materials for life. How does the largest planet in the known universe compare to Stephenson 218? Rox S42b, a planet that is 2.5 times the size of Jupiter, is the biggest planet in the known cosmos. This planet is still significantly smaller than the Sun and Stephenson 218, even at that enormous size. The biggest stars in the cosmos are still being discovered. The maximum diameters of stars are the subject of some scientific ideas. These hypotheses could need to be revised in the future though. For the time being, Stephenson 218 will continue to lead our list of the biggest stars in the universe as we know it. There are many distinct kinds of stars, some are bigger than others. But before moving on, you must realize that stars don't have heat-defined boundaries. They do not have a rocky planet or a moon's solid surface. Instead, the superheated mass of gas that makes up these atomic fireballs slowly thins out into nothingness, leaving them with somewhat dispersed surfaces. It's also crucial to remember that we have never taken a direct measurement of a star. Nobody approached one and began measuring them with a ruler. We do, however, have estimates, mostly accurate estimates, but nonetheless estimates. These estimates can be more or less accurate and fall within a narrower or wider range of confidence, depending on what variety of variables, such as distance or structures surrounding or between stars and Earth. Keep in mind that because stars are balls of extremely hot plasma, they don't have a linear relationship between weight and size like, for instance, cannonballs, where the larger shell is obviously heavier. Put in mind also that despite being one of or actually the largest star we are aware of, Stephenson 218 is not the most massive star in the known universe. Westerhout's 492 W492 wins that contest hands down. The Westerhout 49H2 region has a huge star called W492 that is extremely brilliant. With a mass of 250 solar masses, although this estimate is subject to considerable uncertainty, and a brightness of almost 4 million L, it is one of the most massive and brightest stars that is currently known. More so, despite being much larger, UY Scuti is only 30 times more massive than the Sun. We have covered all the information that is currently available about Stephenson 218, the largest star in the universe, and thousands of times bigger and hotter than the Sun. Who knows? Perhaps astronomers are finding a brand new largest star as you watch this. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.